Continuing with factoring polynomial expressions. So in this lesson, the first 6 questions here are just review of factoring polynomial expressions. Okay, I'm going to skip these in the note video. Please try a couple of these on your own. Maybe at the start of class, we can use 1 or 2 of these as just kind of a pop quiz to review factoring. Okay, but the new factoring method that we're adding today is the factoring of the sum and difference of cubes. So similarly to the difference of squares, we do have a special formula for factoring these. So when we have the sum of cubes, we can factor that as a plus b times a squared minus ab plus b squared. Okay? And for difference of cubes, we have a minus b times a squared plus ab plus b squared. Okay, so these are 2 different formulas that you guys need to memorize. Okay, these are essential to memorize. So for sum of cubes, how I remember it is you are adding your individual terms, but then you are subtracting your trinomial. Where for difference of cubes, you are subtracting your 2 individuals, but you are adding your trinomial. So factor completely. So first of all, we have to check, make sure that we have difference of cubes. In this case, we have x to the 3rd power, x cubed, so we're good. 27, yes, that is a cube as well. So I'll start by finding my a value, which is just the cube root of x, which gives me x, and my b value, which is the cube root of 27, and that is just 3. So I have the sum of cubes, so let's use our formula. A plus b times a squared, which is x squared, minus ab, and I'm going to write this as negative 3x. I know I'm technically writing this as ba, multiplication is interchangeable, and then plus b squared, which is just 9. Okay, and that's my factored form. This first one here wants us to check our work by multiplying, so I guess we can do so. Remember, you would multiply your first term to each of the multiplication, and then you would do the same with the second term. So I take x times x cubed, which gives me x to the 3rd power, x times negative 3x gives me negative 3x squared, and then x times 9, which gives me 9x. Secondly, I have 3 times x squared, which gives me 3x squared. 3 times negative 3x. Sorry, this gives me, yes, we're good, which gives me negative 9x. And then 3 times 9, which gives me 27. And the thing that you guys will notice for this is my x squares are going to cancel. My 9s are going to cancel, which leaves me with x cubed plus 27, which is the same as what we started with. So that means that we factored it correctly. All right, on to page number 2. We'll keep these notes nice and short. First, we have to check to make sure we have the difference of cubes. Remember, 8 is a perfect cube. M cubed is obviously cubed. And then 1 is, cubed, squared, so on and so forth. So my a value in this case is going to be the cube root of 8m cubed. The cube root of 8 is 2. The cube root of m cubed is just m. And then I have my b value, which is the cube root of 1. which is just 1. So for this one, I'm going to use my difference of cubes formula, which tells me I have a minus b times a squared. So I have 2 squared, which is 4, m squared, or m squared, which is just m squared, plus I have ab, 1 times 2m is just 2m, plus b squared, which is 1 squared, which is just 1. Okay? This is my final factored form for a difference of cubes. Okay? We'll skip the ones on the right side. You can save those for class. But in one like number 10, you may notice that you can factor out a greatest common factor first. We have to do that first if it is a possibility. So let's do it. My greatest common factor between negative 8 and cubed and 64 would just be 8 or negative 8. It doesn't matter. But we might as well factor out a negative 8. So if I factor out a negative 8, I have left over n cubed 64 divided by negative 8 gives me negative 8. Okay, from here, I'm looking to factor what I have left over in the parentheses. So I will have my a value, which is the cube root of n cubed, which is just n, and my b value, which is the cube root of 8, which is just 2. Okay, from here, I'm going to use my difference of cubes formula. So I'm going to leave my greatest common factor out in front, which is negative 8, times a, which is n, minus b, which is 2, times a squared, which is n squared, plus ab, which is just, I can just write this as 2n, plus b squared, which is 4. That is my final factored form for number 10 there. All right. Hopefully this gets you guys started with factoring with the sum and difference of cubes. It is just another one of our special factoring patterns. So give the 2 on the right side a try before class. Give those factoring at the start of the notes a try, and you may see some of these popping up on a pop quiz down the road. All right. Thank you guys for watching. Bring any questions you have to class.